In this video, we'll see how to solve the equation sine of 2x equals to square root of 3 over 2 for x less than or equal to 2 pi and greater than or equal to 0. Now, the first thing you really have to do is make a note of the domain over which we're going to be solving this equation. That's going to be very important later. The second thing we'll do is we have sine of 2x equals to square root of 3 over 2. We're going to let capital X equal to 2x. This allows us to rewrite our equation in terms of capital X. And we can now solve sine of capital X equals to square root of 3 over 2. This actually makes our equation much easier to solve. By now you should know how to use a unit circle. And if I make a very rough sketch of a unit circle here, when sine of capital X equals to root 3 over 2, remember, sine is the y-coordinate of a point moving around a unit circle. So square root of 3 over 2 is that y-coordinate here, and it's going to correspond to either one of these 2 points on the unit circle. If I use another color there to make that a little clearer, we're looking at these 2 values on the unit circle. In radians, this first angle corresponds to pi over 3. The second angle is going to correspond to 2 pi over 3. If you wish in degrees, that would be 60 degrees and 120 degrees. So, we carry on. This means that capital X has to be equal to pi over 3, or capital X can be equal to 2 pi over 3. But now, that's just a solution going around the circle once. We have to consider the fact that we could go around the circle an infinite number of times. And to do that, we write capital X equals to pi over 3 plus 2k pi, or capital X can be equal to 2 pi over 3 plus 2k pi. Now that we've done this, we're going to go back to what capital X was actually equal to. Remember, capital X was equal to 2x, which is written here. So, I'm going to use that fact and rewrite what we just found. This will lead to 2x equals to pi over 3 plus 2k pi, or 2x can be equal to 2 pi over 3 plus 2k pi. Since we're looking for x, we have to divide both of these equations by 2. So dividing by 2, the first one becomes x equals pi over 3 divided by 2 becomes pi over 6. And 2k pi divided by 2 simply becomes k pi. And the second equation will become x equals to pi over 3 plus k pi. There you go. We now have to look into all the different possible values that k can take. So the first quite obvious value to use is k is equal to 0. So if I look at the 2 different solutions there, if k equals to 0, my first solution will be pi over 6. And looking at that second equation, the second solution would be x equals to pi over 3. And just check, go back to the domain in which we had to solve it. Remember, we had to solve this for x greater or equal to 0 and less than or equal to 2 pi. So both of those values that we found there, pi over 6 and pi over 3, meet that criteria. The second value for k that we'll take is 1. Let's see what that yields. If k is equal to 1, the first equation will give us x equals to pi over 6 plus pi, which leads to 7 pi over 6. That's also less than 2 pi and definitely bigger than 0, so it's fine. The second equation will lead to x equals to pi over 3 plus pi, which leads to 4 pi over 3. That's also fine, because it's less than 2 pi and greater than 0. Remember, 2 pi would be 6 pi over 3 here. So as long as we don't reach 6 pi over 3, we're safe. We don't actually need to look at k over 2, but I'll show you why we don't have to look at it. If we were to look at k equals to 2, the first equation would give us x equals to pi over 6 plus 2 pi. And the second equation would give us x equals to pi over 3 plus 2 pi. Now the fact is, we have to have a value which is less than 2 pi. And since I'm adding in each of these a positive value to 2 pi, whatever that answer is, it's got to be bigger than 2 pi. So we can ignore these completely. The next values we look at would be k is equal to -1. By considering that value, our first equation would lead to x equals to pi over 6 minus pi. And the second equation would lead to pi over 3 minus pi. But both of these are going to be less than 0, because pi over 6 is less than pi, and pi over 3 is also less than pi. So they'll both lead to negative solutions. So we don't need to consider negative values of k either. So summing up, we have 4 different solutions, which are fine. We had, for k is equal to 0, we found pi over 6, which was okay. We also found pi over 3, which was okay. For k is equal to 1, we found 7 pi over 6, which was fine, and 4 pi over 3, which was okay. Those are our only solutions. So we write our answer to this equation as, well, let's see, if I rewrite everything here, we had sine of 2x equals to square root of 3 over 2 for x greater than or equal to 0 and less than, x less than or equal to 2 pi. The solutions will be x can be equal to either one of the elements inside this set, pi over 6, pi over 3, 7 pi over 6, or 4 pi over 3. And there you go.